Okay, the last assignment of the week is going to use rational equations. And I think that the rational equation assignment may well be the hardest assignment of the entire week. It's the one that I see a lot of students really struggle with. So remember, this whole week we've been working on different kinds of equations. We started with absolute value, and then we did radical, and then we did the quadratic in the form of the Pythagorean theorem, where we undid the square by taking the square root of the number. And now we're going to look at rational equations. I think the difficult thing about rational equations is you're stepping again into the realm of a more complex fraction. And in fact, we don't usually call these fractions because we have variables in the denominator often. And this is one reason why we use the more generic term of rational equations. A rational equation typically has both a numerator and a denominator, and often with a variable in the denominator. The minute we put a variable in the denominator, we need to remember that there is a problem that can arise. And that problem is we can have a 0 in the denominator. And if we have a 0 in the denominator, our rational equation is now undefined. And therefore, we have to take care of that. And therefore, we have to designate the values which will make this undefined. So they're excluded values is one word to call them, or we also call them restricted values. So we're going to list the restricted values in these equations. And so let's start first with just a very simple idea of a rational equation. If I have 1 over 2 is equal to x over 4. Pretty simple. No variable in the denominator, so I do not have to deal with that. Now, this one is really easy because 4 is divided by 2 times, so therefore to get my 4, I multiply 2 times 2. I have to do the same to that, so my x has to equal 2. But not all of them are going to be that simple. You can't just do them that way. So let's do one that's not. Okay, we can see real easy that that is not going to be 1. 7 doesn't go into 5, 5 doesn't go into 7, so there's nothing we can do to the 7 easy to make the 5. When this happens, we are going to use the idea of the cross products. In an equation that is rational and has an equal, these cross products must be equal to each other. So therefore, 7 times x has to equal 3 times 5. And so let's write it up here because I'm out of room. 7x equals 15. Divide both sides by 7. You see how you're using all of your equation solving skills. So x is going to equal 15 over 7. Leave it as a fraction. Okay? And that would be your answer on that one. Let's do another one. Let's look at 3/4 is equal to 8 over x. Now notice on this one, we have an x in the denominator. Therefore, we have to specify that this letter cannot equal x since it's all alone. Our restricted value is x cannot equal 0. You can write it either way, I don't care. One of them, this one identifies it, this one says it can't be that. So we have 2 different ways to write it. This one is a domain form, this one is identify it form, so you can choose the form you like. That's the first thing I'm going to do, is my denominator cannot be 0, so therefore x equals 0 is not permitted. Alright? Now, my next step is to do my cross products. So 3x is equal to 4 times 8, which is 32, divided by 3, and x is equal to 32 thirds. Just leave the fraction, don't go to decimal, just leave it the way it is. This does not simplify because 33 is not a factor of 32. Okay, so let's look at a little more complex. Okay, now notice that my denominators are not the same on this one. I have an x minus 3 here, and I have an x here. So for my restricted values, I'm going to have 2 restricted values because each one of those is going to have to be put equal to 0 to find out what the restricted value is. So if x is equal to 3, 3 minus 3 will make that 0. So that's one of my restricted values. This one is by itself, so it's just going to be the same. So therefore, x cannot equal 3 or 0. There it's in restricted value domain form. X cannot equal those two numbers. Now that we know that, let's do our cross products. And when we do the cross products, if there's more than one thing on the denominator or in the numerator, it has to go in parentheses. So I have 5 times x minus 3 is equal to 4 times x. And it doesn't matter whether the 4x is here and the 5 times the x minus 3 is there. This, you can flip it back and forth. So I'm going to distribute, giving me 5x minus 15 is equal to 4x. I'm going to subtract my 5x. And I'm going to end up with negative 15 is equal to negative 1x. Divide by that negative 1. And I have negative 15 over negative 1, which is a positive 15, is equal to x. So there's my answer. And it's not a 3 and it's not a 0. So it's a very valid, very good answer. So let's look at this one. X plus 5 over x minus 2 is equal to 0. Now, whenever we have a whole number like this on one side, we need to change that into a fraction. Since 0 equals 0 over 1, we're going to replace that 0 with a 0 over 1. Now, the other thing we need to know is the restricted value in my denominator, x minus 2. So just like in that one, x minus 2 is equal to 0. Add my 2 to both sides. So we know that x equals 2 will make this 0. 2 minus 2 is 0. Therefore, x cannot equal the number 2. Now we're going to do our cross products. 1 times x plus 5 is x plus 5. But what is 0 times your x minus 2 and 0's on the outside? It turns this whole thing into 0, right? Because 0 times anything you have is going to be 0. So therefore, we have x plus 5 has to equal 0. Subtract my 5. And x is equal to a negative 5. That is the answer that will make this true. And it's not 2, so we're in good shape. Let's try it. Negative 5 plus 5 over negative 5 minus 2. Does that equal 0? Well, this is a 0 over a negative 7. 0 over negative 7 is equal to 0, so yes, it is true. Sometimes it's good to look at it and see what it's going to give us. Okay, sometimes we add these together before we do our cross products. Okay? So again, notice I have x in my denominator. They're both the same though. So I only have one restricted value, and x cannot equal 0. Now, 9 we can change to 9 over 1. Anytime you have a number that's a whole number, just put it over 1, and it will become a fraction. Notice my denominator's all the same. So all I have to do is add my numerators, which is going to give me 3 plus 4, which is 7 over x, is equal to 9 over 1. Let's make it more even here. Now we can do our cross products. 9 times x is 9x is equal to 7 times 1, which is 7. Divide by 9. So x is equal to 7 over 9. Okay? Not too hard, but that's one way we can do it. Okay. 1 over x plus 1/2 equals 1/7. Okay? Now, on this one, we have a variable in the denominator, and it's all alone, so again, x cannot equal 0. But I'm adding a fraction to this one with a variable, and it's equal to another fraction. Whenever we see this kind, we've got a number of different methods we can use. But for right now, if you use another method, I'm not going to be upset with you. But for right now, I think for a lot of you, because we're working a lot with cross products, it would be easier if you took this fraction that's all numbers and subtracted it from both sides. Okay? That makes that 0, leaving you with a 1 over x equal to. But now we've got to find that common denominator and deal with this. I'm going to move this over further. So 14 is going to be my common denominator because 2 and 7 are both prime, so that's the only way we can get it. So 2 times 7 is 14, so therefore times 7 is a negative 7. 7 times 2 is 14, therefore that's a 2. Therefore 2 minus 7 is going to give you a negative 5 over 14. Don't lose your denominator. Now we can do our cross products. X times negative 5 is negative 5x. 1 times 14 is 14. Divide by your negative 5, and x is equal to a negative of 14/5, and just leave it in that fraction form. It's just fine. And that is not 0, so we have a valid answer. Okay. You will be ready to do that assignment. I'm going to just do a refresher on a few things that we've already done with this video as well. I think we've got enough time. So we're going to look at a refresher on some of our basic skills that go into this. First one is adding fractions. So how about 4 over x minus 8 over, let's go 9. Okay? To get our common denominator, all we can do is multiply our 9 and our x. So this is 9x, and this one is 9x, because they have nothing in common. Remember, x can't equal 0, but we're not going to write that down. We're just worrying about doing the operation. So 9 times x here gives you 9x, so we'll have to multiply 4 times 9 to get 36. 9 times x here is 9x, so we'll have to multiply that by x, and we get an 8x. Therefore, 9x is my common denominator. You just write it. 36 minus 8x is all you can do. So you're going to end up with an expression on top when you have that kind of a fraction. Those are the ones that I know you're going to have trouble with, so I went through that. The others we've already gone through in assignment number 2, where you're just using all numbers and either adding or subtracting. I just want you to have a little more practice on that one. I've already given you that one at another day. Okay, changing fractions to decimals is another thing I'm going to have you do again. Reason why is you're going to use these kind of things a lot, so you might as well get good at it. Okay, how about 1 over 6? Divide your 1 by your 6, and I really don't care if you use a calculator on this. 1 divided by 6 gives you 0.16666. And they put a little line above that because it means that 6 goes on and on. But I want you to round these to the nearest thousands. So we're going to look at 4 decimal places because we want to keep this one. So we're going to look at this one. It's more than 5. So it's going to make this go up. So this is going to equal 0.167. 3 places is your thousandths place. And there's quite a few on this short worksheet that you're going to have to practice your rounding skills because you're to round to the nearest thousandths place. Be sure to write them 4 decimal places. If this is 5 or greater, you're going to round to the thousandths by moving up. If it's less, you're going to move down. How about 1/3? 1/3, if you divide it, is 0.3333, and it keeps on going. We want to keep this place value. 3 is less than 5, so you just cross it off. And so this one is 0.333. Okay? So that's that particular worksheet that will be part of this assignment. And changing decimals to fractions again. Okay, let's look at that. 0.35, that's 35 hundredths. So you're going to write it as 35 over 100. Divide both by 5 to simplify. And you're going to end up with 7 over 20. And that's going to be the final fraction. So this is just going to be some extra practice in those particular kinds of activities. And they will be attached to this rational equation worksheet. So that's your worksheet for this particular assignment. And good luck, and I hope you can get through it. Remember, I'm just a phone call away, a text away. You can get on Zoom, you can get the help you need, or you can use the tutor. So anyway, see you later.